Hello students, this video is designed to help you with the mini-mock pre-test 2 that you took in the Common Core Algebra 1 class. I'm going to be going over some of the selected questions that you folks got wrong on the test and show you how to get the right answers. If you take a look at the first multiple choice question, which was the expression 6 minus x quantity squared is equivalent to, in order to answer this question, you needed to use the double distributive property. I'm going to show you what I mean here. And what I did here was I took the expression and expanded it into two different polynomials that are multiplied together, two different binomials. I know that x minus 6 squared is equivalent to x minus 6 times x minus 6. Now I'm going to use that double distributive property that I talked about before. So I'm multiplying this first x, the first term, times every term in the second parentheses. X times x is x squared, and x times negative 6 gives us negative 6x. Next, I'm distributing the negative 6 term to every term in the second parentheses. Negative 6 times x is negative 6x. Negative 6 times negative 6 gives us that positive 36. Now I'm going to take these two middle terms and combine them because they are like terms. So I combine my like terms to get negative 12x. I know my final answer is x squared minus 12x plus 36. There's my correct answer. The next one I want to go over is question number 35. It says the graph of y equals f of x is shown at right. All of these 4 points are y equals f of x. It identifies f of negative 2. Now f of negative 2 is telling us something very specific. It tells us that the x value is negative 2. So I've identified the fact that x is equal to negative 2 because my original function says y equals f of x. That x value is replaced here with negative 2, which means my x value must be negative 2. Looking at the points, I can see that there's only one point, that's point C, that has an x value of negative 2. A has an x value of positive 2, it's here 1, 2 away from the origin. B has an x value of 0. D has an x value of negative 1. C has an x value of negative 2 because it's minus 2 from the origin. So if x is equal to negative 2, the point must be point C. Conveniently, choice C. I want to go over the very next problem, which is question number 36. It gives us a function here which is split up into 3 different pieces. This type of function is called a piecewise function, and I want to talk briefly about what that means. And you can see I wrote a definition here, a function which is defined differently for different x values or domain values. I can see that the function is supposed to be x plus 4. X plus 4, you know, is a linear function. And that's only when the x value is less than negative 3. When the x value is in between negative 3 and 3, it's no longer a linear function, it's now a curved quadratic function. And then when the x value is greater than 3, it's a function that looks like this with negative x plus 4. That's another linear function. I want to show you briefly what a piecewise function looks like, so I graphed it on a website. So you can see what it sort of looks like when x is less than negative 3. It's this x plus 4 line, this straight linear function. From negative 3 to 3, from here all the way to here, it's a curved function, a parabola, which goes a little bit higher than the graph shows. And then when x is larger than 3, from here upwards, and upwards we're talking about upwards in the x direction here, it looks like a linear function with a negative slope. So that's what the function looks like. A piecewise function just looks like 3 different pieces, in this case 3 different pieces, or 4 different pieces, or 2 different pieces, however many pieces it is, on a graph. All that being said, it said the owner of the building wants to know how tall the roof is when x is equal to 3. Well, we need to look at all of these restricted domains, all of these conditions, and see which one fits x is equal to 3. When you look at x is equal to 3, I know that this says x is less than negative 3. That's not going to work because my x value is 3. This says x is in between negative 3 and 3, and it says x can be equal to 3. There we go. We know that our x value fits that criteria. We also know that this says x is greater than 3. Well, that's no good because this says x is equal to 3. So we can cross that one off, and we know that this is our function, negative x squared plus 10. So what we're going to do is take this x value, substitute it into the function. So I knew my function was negative x squared plus 10. So in my calculator I did negative 3 squared plus 10. That gave me 1. That's my y value, my output value. So I'm looking for all the different y values here. I got 7, 19, 1, and 3. My correct answer is choice B, 1. We're going to move on now to the short answer questions. The first short answer question gives us a function and says graph the following function. Anytime you get a question like this, you say, oh, thank you so much, Regents writers. All you have to do is take this equation, put it into your calculator, and graph the points that it gives you. So we'll take a look at our calculator and find the appropriate points. So here's our calculator. Remember, we did this calculation just a few seconds ago. I go to my y equals menu, and it looks like somebody's been using it before, so we'll clear it out here. I want to input this function, which is f of x equals x to the third minus 3. So what I'm going to do is take f of x and realize that that's equal to y. The equals is already there. I'm going to put in x to the third, and I'm going to use the variable button x, this exponent button, and 3. If you have a newer calculator, it might have made it pretty by making the 3 small, but this is an older calculator, so I guess just deal with it. Minus 3 goes here, and now I can look at the graph, and the graph looks like a sort of weird graph. This graph is called a cubic graph because this is x to the third, x cubed. In order to graph this, though, I'm not going to look at the graph. I'm going to look at the second table. Now, I can't graph all of these values. For sure, I can't graph negative 1,003. But I'm going to scroll down until I can find some values that I can graph on this graph. And the first one I can is negative 1, 4. I'm going to start graphing these points, and we'll see what the function looks like. So here are all the points that we're able to graph from the table. And I look at this and I say, well, it doesn't really look like I can connect these in a straight line. Remember, if you go back to the graph, it's not a straight line at all. It looks like this little curvy thing. So what I'm going to do is I'm going to try to make this here. And I'm going to notice that this piece where it's curving is this piece where it's intersecting the y-axis. It's y-intercept. So it's going to look a little bit like this. Now, I'm no artist, but I'm sure that you can try to do something a little bit similar to this. Remember that it is a function that is ongoing. It's going to keep on going infinitely in the positive and negative y directions. I'm also going to make sure that I label this graph to show what function it is. So it's going to look like this. So there you have it. You've graphed it. You've given it a label. There's 2 easy points. Moving on to question number 46. It's asking me something very similar. It says, draw the graph of y equals 2 to the x over a certain interval. Now before, it didn't give us an interval, but now it does. The interval says we're only supposed to graph for the x values that it asks for. So I'm going to pull up this graph now, go to my y equals menu and clear it out. I need y equals 2 to the x. So I already have y equals. I'll put 2 to the power of x. I know this is an exponential graph because exponential has x as its exponent. If I look at the graph, it looks like a typical exponential function. It's going to start going fairly slow, and then it's going to increase in its slope. Its slope is going to increase dramatically. Now I'm going to look at the points, but remember, it told us only look at negative 1 to 3 for the x values. So I'm not going to try to graph negative 2, 0.25. I'm only going to graph from negative 1 to 3. So the graph is going to look something like this. Here you can see my points. I graphed from negative 1 to 0 to 1 to 2 and to 3. I've only graphed the points. I haven't connected it yet. And I want to point out that since my interval has less than or equal to here and a less than or equal to here, I'm not going to have open circles at these points. I'm going to have closed circles because we're allowed to use those points as valid solutions. Now let's take a look at what the graph looks like when we connect the dots. Here we are with the connected graph. Believe me, this is the best I could do with the materials that I had. I'm sure that you can do a better job with pen and paper, or pencil and paper, as I should say. You're finally going to label this graph, and then you're done with that section of this question. I've labeled the graph, and now I'm done with this part. Keep in mind that I don't have to label the interval. You don't have to label the interval because you can see clearly that we're starting our x values at negative 1, we're ending our x values at positive 3, so there's no need to take this interval and write it here. I'm just labeling the graph so that people can see that this graph represents this particular function. The next part asks whether the graph will ever intersect the x-axis. This is a theoretical question based on the idea of exponential functions. Well, we can test it out by looking at the table. I know that intersecting the x-axis, that piece of information is asking whether the graph is going to have a point with the y value of 0. So we're looking for a point with a y value of 0. So looking at the table, I can see that the y value is decreasing as I go to my negative x values. If I keep scrolling up, I'm looking at decimals that are getting smaller and smaller and smaller. And now I'm getting into scientific notation. A number like 6.10 times 10 to the negative fifth, that's 0.00006. This number is going to continue getting smaller and smaller, but I'm never going to get to 0. And that should make sense because of this reason. Here's my equation, y equals 2 to the x, which means I multiply by 2 every time I go from a point to the next point. From here, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, etc. But that means going backwards, I'm going to divide by 2. 1 divided by 2 is 1/2, divided by 2 is 0.25, divided by 2 is 0.125. I'm going to keep dividing by 2, but I can never divide a number by 2 and get 0 unless the original number was 0. So the question was, will this graph ever intersect the x-axis? Well, no, because it doesn't matter how many times I divide by 2. I can always cut it into half, and I'm always going to have something left over. So I wrote out a brief description here. The y value is never going to reach 0 because since the y value is being halved each time, the x value decreases. Dividing a number by 2 is never going to result in 0 unless, of course, you start out the original number, with the original number being 0. We're going to move on to the next page of the pre-test here, the short answers. Question number 47 asks, what is the solution of the system of equations below? What we can do to solve this system of equations is, well, there's a couple different things. We could graph both of them and see where the two lines meet. We could take one of them and substitute them into the other, or we could use elimination to try to eliminate one of the variables and then solve for the other one. I'm going to show you two methods. The first method I'm going to show you is the elimination method. I wrote these two equations vertically. Now I notice that this 2x and this x are lined up here, and all I need to do to eliminate this x is multiply every term here by -2. That would make this positive 2x and negative 2x. So I multiplied every term by -2. Now I have negative 2x minus 2y equals -6. Now what I'm going to do is combine these entire equations together by adding them individually. These two terms eliminated. 3y minus 2y gave us y, and 7 minus 6 gave us 1. Simplifying, I know that y is equal to 1. Now I have to take my y value, substitute it into one of the equations, and determine the value of x. I chose the second equation because it was a little bit easier to work with. X plus y is equal to 3. I knew that y was 1, so x plus 1 is equal to 3. Subtracting 1 from both sides gave me x is equal to 2. Now I'm going to show you the substitution method. Here I subtracted y from both sides of the second equation. I solved this equation for x. Once I solve for one variable here, I can take that one variable and substitute it into the other equation and then simplify. So you notice that I wrote 2x plus 3y equals 7, and then I replaced the x. I substituted the x with 3 minus y. This piece was the substituted piece. My next step was to distribute 2 times 3 and 2 times negative y. Now I have an equation that I can combine like terms and try to simplify even more. I know that negative 2y plus 3y gave me y. Now I'm going to try to isolate y and solve for that variable. And you'll notice I got y is equal to 1, which is the same as this left side. Substituting this y equals 1 into my other equation will get me the value of x. So I'm going to get the solution, which is x equals 2 and y equals 1. Regardless of the method I use, I still have to state the solution to the system of equations. So I'm doing that here by saying the solution is 2, 1. I found my x value to be 2 and my y value to be 1. Those are the questions that I wanted to review with you. Again, this has been a review of Common Core Algebra 1's Mini-Mock Pre-Test 2. Hopefully this was able to answer some of your questions. Good luck studying.